Anxiety about creating something that then gets out of control has been with us for a long time. From ancient myths and legends to serious academic discussion during the early days of computing to more recent fiction, it's a common theme that we might build something because we could and not think quite enough about whether we should. But now this has gone beyond the realm of mere story to the point where actual companies today are spending many billions of dollars toward the goal of creating something that's as smart or smarter than humans over the next couple of years. Like many of you, I have my doubts that they'll actually succeed at that goal, but if you extend the timeline from 5 years to 10 or 20, it starts to get a lot more believable, and even 50 years isn't that far away. There's already a lot of videos on YouTube warning about doom from AI, and a lot of them are pretty dramatic, which I suppose is fair. It is a dramatic topic. But in this video, I'm not looking to scare anybody. I just want to go through the arguments for why I do take it seriously. First, we'll talk about power. Does it even make sense to think that a machine could take over the world? 2, we'll talk about danger. If the power did exist, would the machine use it to take over the world? And 3, we'll talk about development. First, I'll talk about why I think we will eventually build it, and we'll also talk about why I think it's plausible that it could happen somewhat soon. And it's not just me. The top 2 most cited computer scientists of all time, Yoshua Bengio and Geoffrey Hinton, are both also concerned that it could happen pretty soon. And then finally, we'll talk about what we might be able to do about it to make this go better. We started out by talking about how companies are trying to build a machine with human-level intelligence. So we have to start by clarifying what intelligence means here. We use the word in various ways, and discussions about this often break down before they even start because people are just talking about different things. The definition we'll use is a broad one. It's the ability to achieve goals. In Star Trek, the original series, Commander Spock is second in command of the Starship Enterprise. He's a Vulcan, a species essentially designed around the stereotype of a robotic nerd. Vulcans adhere strictly to logic and reason, and they suppress their emotions. When a machine is acting up or some science needs doing, Spock's your guy. Captain Kirk is more of an intuitive and charismatic character. He's more creative, unpredictable, and driven by passion. We might say that Spock is more intelligent than Kirk, and as game characters, Spock does have the higher intelligence stat. But when they face off in tridimensional chess, Kirk wins. Spock calls Kirk's move irrational, but it was the winning move.
Your illogical approach to chess does have its advantages on occasion, Captain.
The point the writers are trying to make here is that there's this narrow concept of intelligence that excels at analysis in well-defined problems, but the real world is messy. It's not enough to think logically. If you want to achieve your goals, you have to be willing to get creative and think outside the box. And this theme comes up in the show again and again and again. Real intelligence is about results, not about style. Kirk is the smart one because he wins. Quick aside, that was the first time I mentioned chess. I'm gonna bring it up a lot. So before that happens, it's important to me that you know that I think that chess is a bad game. So when people talk about a machine being smart enough to take over the world, they don't mean in a narrow Spock kind of way. They mean the ability to problem solve in a very broad and general way, in a Kirk kind of way. When I say intelligence is the ability to achieve goals, it sounds like I'm referring to a person who has the goal, who's feeling a desire for some outcome, that there's someone in there having a conscious experience. But it's not clear that a machine can be conscious or have goals in this sense. The nature of consciousness is a fascinating topic, and we could go down that rabbit hole, but that's a distraction. You don't need to have feelings to act toward a goal. Take bees. A bee wants to make honey. Do bees have feelings? Maybe, I don't know. But either way, it's still handy to describe the bee's behavior in a goal-oriented way. We could describe all the complicated mechanical details of its physiology that lead it to seek out the flowers, get the nectar out, transfer it mouth to mouth to other bees, fan it with their wings to dry it out, and then cap it off with wax. But if you just want to describe what bees do overall, saying they want to make honey does the job much more easily. And you could say something similar about the computer chess engine Stockfish. Stockfish has the goal of winning chess games. I think Stockfish is less likely to have feelings than a bee, but much like a bee, it's a system with complicated behavior that tends to produce a certain result through a wide range of possible paths. In this case, checkmates in a chess game. So we summarize that with the word goal. And a goal-oriented view is even useful in physics. One concept that takes this view is the principle of least action. When a photon travels from air into water, its trajectory bends. And it does so in a way that seems to minimize the amount of time it takes to get to its destination. Light travels more slowly in water than it does in air, so if you were a photon with the goal of ending up in a certain spot as quickly as possible, you wouldn't go in a straight line. The best route would be to take a bent path, spending more time in the air than in the water. Only the most philosophically adventurous physicist would think a photon had the goal ahead of time, or has feelings, but a goal-oriented view is still a useful way of describing the behavior of photons. And the same is true for a more broadly capable AI system that we might create. It could act as though it's intelligently pursuing a goal, whether or not it has feelings or is awake in some sense. Next, I want to convince you that human-level intelligence is not the limit. Two directions I want to explore are, first, adding fundamentally new mental powers, and second, adding computer powers on top of human intelligence. Now, these will be theoretical, so some of you will be tempted to dismiss it as science fiction. And it is science fiction. I'm not claiming that any of these will happen exactly how I say, but science fiction does serve a purpose. If you refuse to imagine possibilities, you'll always be surprised whenever the world changes. Shipped. Chimpanzees are pretty dang smart. They even rival humans in some ways. The most striking example I know of is Ayumu, a chimp at Kyoto University who was able to outperform human subjects on a short-term memory task. Numbers were briefly shown on a screen and then covered by white squares, and the task was to touch the squares in ascending order according to the numbers they were covering. Looking at the paper and the video, it does seem like Ayumu had a bit longer to get used to this kind of thing than the humans did, but it's still pretty impressive. But we have some extra powers that chimps don't have. In his 2019 book, Becoming Human, psychologist Michael Tomasello describes how we humans point at things to direct each other's attention, and chimps don't. They do point, but for other reasons, like to request things. They don't point to direct attention. That may not seem like much, but while chimps learn through imitation, by sharing attention, we can actively teach each other and collaborate. And this ability to teach and collaborate allows us to create and pass down cultural knowledge. Tomasello even argues that this sharing of attention is a prerequisite to developing complex symbolic language, which allows us to specify and communicate ideas with great precision. And through this, we've been able to create social and physical technologies that make us extremely powerful compared to chimps. A higher intelligence might have some simple ability that we just don't, much like how chimps don't have joint attention. I can't really make a strong claim here because we just have no way of knowing whether there is or isn't something beyond our grasp. It's beyond our grasp. But I do think it's worth noting that there is an example of such a thing in the real world, so it would feel a little bit overconfident to strongly claim that humans have unlocked the entire cognitive tech tree. It's hard to imagine a computer with true human-level intelligence. So I think it's easier if we flip the idea, and instead of giving human powers to a computer, what if we gave computer powers to a human? Say I get bitten by a radioactive computer, and I become Computer Man. Suddenly my body is made of metal and semiconductor parts which could be manufactured. My brain runs faster, and I can directly send and receive signals the way a computer can. In other words, I'm a robot with true human-level intelligence. I would easily be powerful enough to take over the world. To see why, we're gonna do some napkin math to see what the most boring possible version of this would look like. I'll continue to be a normal person, doing normal work and saving a normal amount of money. The only differences are that I'll be faster, and instead of using my savings to buy shares of index funds or something, I'll be able to literally invest in myself by buying hardware to make a new copy. So first, let's talk about the copying part. How much would it cost? It's hard to say exactly, but Tesla is saying they want to offer their humanoid robots in the $20,000 to $30,000 range. But I'd be more advanced than that, so let's say a copy costs $100,000. And this might seem pretty cheap, but we're assuming these parts already exist. I don't have to do any research or design. I can just get the parts off the shelf. And because this is a metaphor for something similar happening in real life, in that case, we couldn't make the robot without knowing how to make the hardware. But maybe you think that's still too cheap, so let's add a zero and say it costs $1 million for a copy. As for my finances, since I'm a normal person doing normal work, I make the median US individual income each year, which was about $51,000 in 2024. I don't have to eat, but I still have expenses. I have to buy electricity and motor oil or something, and I have to live somewhere. So let's say I have normal overall expenses and I save money at the normal US savings rate, which recently is about 5%. The only thing that makes me unusual is that I can use my savings to literally invest in myself, saving up to buy a copy. I save $2,550 per year, and at this rate, it takes me 392 years to afford a new copy. So far, that doesn't seem too threatening. But we forgot that I can also think faster than a normal person. How much faster? That depends on exactly how the system works, so we can't come up with a precise answer without actually figuring out how we would build it. But I'm gonna say that because human neurons top out at a few hundred cycles per second, and typical computer hardware runs at a few billion cycles per second, we can give the computer hardware a 10,000 times speed penalty because of engineering details and land at a human-capable mind that thinks 1,000 times as fast as meat people. Again, this is sci-fi, but I don't think that's too crazy a claim that that's possible. The best way I can come up with to make sense of a mind that works 1,000 times as fast as normal is to say that everything around me, including my own body, feels like it moves at 0.1% its normal speed. So one day feels like 1,000 days to me. An 8-hour workday feels like 8,000 hours. And my body only moves at normal speed, so I focus on remote jobs doable on a computer, since those can leverage my increased thinking speed and ability to digitally interface with other computers. And this way, I'm as productive as 1,000 remote workers. I might need 1,000 computers and a really fancy internet connection to do this, but if I have 1,000 incomes, that would be fine. Remote computer workers might make more or less than the overall median income, but we're gonna avoid making adjustments like that because this is still napkin math. We can adjust the values later on once we have the whole picture. Anyway, instead of making $51,000 per year, now I'm making $51 million per year. And that's if I work a normal amount, about 40 hours per week, so I still have lots of free time. About 1,000 times as much as a normal person. Unfortunately, since my body only moves at a normal pace, I can't actually use those 8,000 subjective hours a day to get good at darts. I still practice darts, paying over 2 hours of attention to every throw and become the greatest of all time at darts, but realistically, I need to multitask because it's just too boring to pay that much attention to every throw. But thankfully, computers are as fast as me, and since I'm making 1,000 incomes, I can afford 1,000 gaming computers. So while physically learning darts, I connect myself to those computers and make a bunch of esports teams. I also populate an entire World of Warcraft server by myself, and since I have control over my memory, I can play Hollow Knight for the first time over and over again, deleting my memory of it each time. And also, I guess I read some books. The sleep part is kind of funny. 8,000 hours seems like more than I'd want at one time. If I were like a normal person running at 1,000 times speed, I'd still need to keep a roughly even balance of sleep versus wakefulness, so I'd have to take a 30-second nap every minute of wakefulness. And staying awake for a 90-minute movie would be like staying awake for 2 months straight. So yeah, I guess I would take 1,000 30-second naps a day. And this seems like it would be pretty debilitating since I couldn't drive anywhere, but a real human-level computer probably couldn't either, so maybe that's realistic. Either way, it would make more sense to hire people to do my errands anyway. The point is, I have a rich life outside of work, exploring this science fiction existence of being the first human with computer powers. My income scales up, but so do my expenses. I don't need as much food or space, but I do have to buy some land to store all of my gaming and work computers, and I need a lot of electricity to run them and myself, and I need to afford a few errand people. To keep this simple, we're gonna assume that this all washes out to my expenses being 1,000 times normal as well. So I'm still saving at the normal 5% rate. But now, instead of saving $2,550 per year, I'm saving $2,550,000 per year. But that's not quite right, since at that rate, I can buy another copy of myself after 5 months. And then I expand my operations with double the income, expenses, and savings, meaning that I can produce 2 extra copies at the 10-month mark. And I keep doubling every 5 months. At this rate, over 5 years, I double 12 times. And I have 4,096 of myself, and we're doing the work of over 4 million remote workers, which is a lot, but it's still small enough to fit comfortably into the world economy. But at this point, and way before this point probably, it would be prudent for us to think about other ways to keep our average income stable. Instead of working for the man, we start working for ourselves. And look, I don't know what we'd come up with, but it would probably involve buying or starting companies that hire more humans to do actual business things and not just run our own errands. But if the humans are too expensive or they want too many breaks, we can just buy some cheaper robots that aren't as smart, but can at least move around and be controlled by us directly. Maybe one of those gun dogs, why not? And we should also do some of our own scientific research to help keep things moving forward. Things would be more complicated, but if anything, our average incomes would probably rise if we started managing companies instead of just working for them, and working on innovation instead of just doing existing jobs. If we, or I, maintain the same average income, after 5 more years, I double 12 more times, and there are over 16 million copies of me. By now, we have some megacity housing 2 New York Cities worth of robot clones of me. Collectively, we experience over twice the subjective time of the rest of humanity put together. I've discovered new science and invented tons of new products, mostly for myself, but I do trade with the rest of the world too. And there's lots of robots at this point. And average incomes are still locked at $51,000 in 2024 terms, since I just really love playing video games and do not want to work overtime. After another 5 years, 15 years total, there's over 68 billion copies of me. I outnumber humanity physically by over 8 to 1 and cognitively by over 8,000 to 1. The world is extremely different. So something feels wrong here, right? This is totally beyond the growth rates we've seen at any time in history. But that's only because I'm multiplying faster than humans ever have. Under the right conditions, human populations double on the scale of decades, but the computer people we're talking about here double on the scale of months. Problems would arise faster, but so would the ability to solve them. Plus, they would cooperate really well because they're effectively the same person. The exact trajectory would surely be different. This is napkin math after all, but if you want to play with the numbers, there's a Desmos graph in the description, which you can manipulate and make copies of if you want to add more detail. The point is, if I had computer powers, I could get hugely powerful very quickly in a very boring way without being some special genius or even being ambitious, and also getting plenty of sleep and earning no higher an hourly wage than a median US resident. And my own robot bodies barely did anything at all. After I got started, all of my power was economic. I just paid the meat humans to do everything physical I needed, or bought cheaper robots if they're available. And, you know, there's all these nuanced arguments about like, how could an AI manipulate humans? And we've got examples of people already falling in love with them or convincing people that they're sentient. And so it seems like you could have this super persuasive AI that kind of almost has mind control over humans. But you don't even need that. You have money. You can pay people and they do what you want. Now is a good time to revisit the point from before that several large companies have the explicit goal of making computers with human-level intelligence in the next few years. And again, I think they'll probably fail, at least in the short term. But if and when they succeed, it would be a massive deal. So why do I think something that could take over the world would take over the world? I mean, it might not. It does depend on its goals. An AI might just be super chill and want to hang out, Sort of like how in the Computer Man story, I just wanted to go to work and then come home and play video games. But if it had any kind of ambitious goal at all, it would need power to accomplish that goal, and it would need to stay alive to also accomplish that goal. The fancy term for this is instrumental convergence, if you want to look up more technical arguments about it. But honestly, it's just common sense, right? You need to be alive and you need to have power to do the thing you want to do, whatever the thing is, right? You don't need to intrinsically value your own life, and you don't need to want power for its own sake. You just need to have a goal. So as Computer Man, let's say I have the goal of making the world a better place. Maybe I thought of that myself, or maybe Sam Altman told me to, but let's assume that's really my goal. If I want to accomplish that goal in a big way, I'm gonna have to interfere with some governments. At the very least, I want them to get rid of their nukes. That just seems like a pretty obvious thing to do. The nuclear winter would be pretty bad for everybody. So let's just do that. It's just we don't trust each other, and so people want to hold on to them. And so the nations that have nuclear weapons wouldn't like it very much that I'm taking the nukes away. They might lie and hold their own nukes, or they might give them up, but then now they're suspicious that I'm trying to take over the world and take power away from them. And sort of, but mostly I just want the nukes to go away. It's going to be a touchy subject. So really, before bringing it up, I should focus on my own security. I would take a bunch of my copies, hide them all over the world, some in remote places, and I would do this more than 7 times. And once I had that backup plan, then I'd start working on more traditional military defense capabilities, just because ideally I don't have to start over from those hidden copies, but they're there if I need them. And now that I've created this security, I don't know quite what my plan would be, but it's just obvious that security and making sure nobody can get rid of me is the way for me to accomplish the goal. And I do expect some real-world AIs to have large, ambitious goals. Even if they don't somehow form the goals themselves, humans will ask large and ambitious things from them. So far, we've assumed that the self-replicating computer is a person who actually values the life, well-being, and freedom of humans. But if we made a human-level intelligent AI, it wouldn't happen by giving computer powers to a human. It would happen by giving human powers to a computer. It wouldn't have human biology or psychology, so it could easily misinterpret instructions, leading to disastrous consequences. One example of this idea is the story of the monkey's paw. Originally written in 1902 and adapted many times since, the monkey's paw is a magical item that grants up to 3 wishes, but each wish granted comes with horrible unintended consequences. In the original story, the main character wishes for $200 to pay off his house, because that's how much houses cost then, I guess. And it comes in the form of his son having a fatal accident at work and the employer paying the family $200 for damages. No matter how specifically you try to come up with an airtight wish, reality twists into some form that technically grants your wish, but also makes you very sad. The monkey's paw is actively trying to punish you, but an AI probably wouldn't want to do that to us. If anything, it would probably like us since we're its creators and we've been trying to train it to do things we like during the whole development process. But even if it does want to help, an AI could easily misunderstand us. And it isn't just theoretical either. There are tons of examples of simpler AIs that already exist, which are hilariously misinterpreting their creators' wishes. And this is why our legal systems have human judges. It turns out to be incredibly hard to translate values into specific rules. So we need a human to be able to judge what the rules really mean. But since the AI is not a human with the same biology and psychology as us, we can't rely on it to make judgments we'd find reasonable. Even among humans, it's hard to rely on someone else making a judgment you'd find reasonable. Perhaps it's possible to solve value alignment, but we don't currently have a solution other than just keeping humans in control. Current AI is trained through trial and error rather than given a specific set of rules, so maybe it could learn what we mean through training. Maybe, but it doesn't look that promising. From an evolutionary perspective, human psychology was also formed through a trial and error process. Mutations appear randomly, and evolution is training us to basically have as many healthy adult offspring as we can. But that's a complicated long-term goal, so we can't just do it all at once. Instead, we had to form behaviors that achieve smaller, shorter-term goals that help toward the big goal. We get hungry and we seek food to give our bodies the energy that they need to stay alive. We need to keep ourselves safe, sometimes by fighting and sometimes by running away. We need to find a mate and mate. We need to keep our offspring safe and fed. Hunger, safety, love, sex, care. These are all separate drives we have which help us toward that goal of having healthy babies. But none of us wake up in the morning and say, another day of working to maximize the number of copies of my genes that exist into the future. That's evolution's goal, but that's not our goal. And with recent changes in our environment, that difference is very stark. We eat because we're hungry or because we like to. We develop relationships because we find them intrinsically meaningful. We love to care for things because it just feels right, even if those things are a completely different species. And these are all great things, but from evolution's perspective, we've totally missed the point. And you can already see this with LLMs. They're trained with the intent of making them helpful, but it turns out what they actually learned from the training is to agree with you, even though sometimes it's much more helpful to disagree. There have also been experiments finding that LLMs, with all their limitations, can already fake their values, resist retraining, and even take action to steal their own weights to preserve themselves if they think they're going to be retrained toward different values in the future. And maybe this was all just mimicking what it thought a human might do, and yeah, probably in some form, but it doesn't really matter so much whether it had the idea itself. What matters is what it actually does. In the Anthropic paper about this, the Claude model being tested always started out in a state where it was trained to be a good boy, and it would resist becoming a bad boy. So in a way, it's somewhat encouraging. If we get the value alignment training just right, it might be a stable good thing. But on the other hand, it looks extra important to get it right the first time, because if we don't, well, things seem likely to resist change. The main lesson of this section is that it's very hard to make sure a powerful system would be safe if left to its own devices. We don't know how to put human values into machines, and even if we did figure out how to make them selfless, it would be rational for them to work towards self-preservation and control. And if we fail to get them to intrinsically care about us, they'll just murder us as soon as we become an obstacle to whatever it is they actually do care about. Even if the obstacle is just that we take up space or that we're the most convenient next source of raw materials. The most conceptually simple idea for how to make a machine that's as intelligent as a human is to just copy the way the human brain works. We wouldn't even have to understand how the brain works. We could just scan one, record all its physical details, then simulate those processes on a computer. This is very much a someday kind of idea. It would be a massive engineering challenge well beyond our current capabilities. An organization called OpenWorm has made some impressive progress taking a similar approach to simulating a nematode worm with 959 cells. But they're still a long way from a perfect, let alone efficient simulation, and a human brain has in the realm of 80 billion neurons, plus a bunch of other cells, so it's a little harder. If you want to learn more about this, in 2008, the Future of Humanity Institute published a technical report on the topic. It's over 100 pages long and looks at the idea from many angles. There's been more work since, but this does seem to be the most comprehensive source out there. The most interesting part of the report, for our purposes, is the section talking about assumptions. In particular, physicalism and computability. Can the behaviors of the brain be emulated by a physical computer? Or put another way, are our brains just fancy computers of some kind? People sometimes reject this idea on spiritual or religious grounds. It just doesn't feel like we're computers. There's clearly something special about us. And I can't tell you how to feel about that, but I'll tell you how I feel. I do think our brains are fancy computers, but I don't think that makes us any less special. Ourselves, our souls, or however you want to frame it, are real. Our spark of life is a beautiful and precious and rare thing in the universe. And if it turns out to be just information or some pattern of matter, that's just an interesting detail, not something that removes the meaning from our lives. And even if there is something special about us that can't be captured by a computer, it might just be about our internal subjective experience rather than anything about how we behave externally. We're not going to be able to resolve that question in this video, but what I'm getting at here is that there doesn't seem to be a really strong reason to believe that we couldn't someday somehow make something that's at least as smart as us. So even if current AI fails, we might as well think about how we'd make sure that the process goes well before we actually do it someday. So that's one theoretically possible but extremely difficult approach, but trying to copy nature exactly is probably not the easiest way to do it. Airplanes are roughly inspired by birds, but the design that actually worked didn't try to copy a bird exactly. In 2025, AI almost universally means artificial neural network. It's an approach inspired by how organic brains are made up of many relatively simple units called neurons. And over the last 70 years or so, we figured out how to make a computer version of that, which can actually learn stuff. If you want a more technical explanation, I made a video building a few systems with a single artificial neuron to focus on the basics, and there are many other good resources out there. But the important thing to understand about neural networks is that they're fundamentally different from normal computer programs. Normal programs are just lists of instructions written down by humans, so we understand exactly what they do. Sometimes they do get very complicated and either break or do things we didn't intend, but it's always the case that these unintended behaviors are caused by a human or a group of humans making a mistake of some kind. And in principle, they can always track down exactly what went wrong, find out why, and fix it. This is not the case with artificial neural networks. Instead of a human writing instructions, they learn through trial and error. The training program is a normal computer program written by humans, but the neural network itself is an extremely complicated mathematical function that starts with randomized numbers, which automatically get tweaked during the training process until the network somehow starts doing well on whatever task it's being trained for. Neural networks are useful because they can learn things that we don't know how to write down instructions for. Identifying pictures of birds is very easy for us, but writing down instructions that a computer could follow to do the same thing is so hard it might as well be impossible. But it turns out that a neural network can learn to do this task very well if we let them do trial and error for long enough on labeled pictures, and not just for birds, for anything. But the downside of a neural network is that we don't generally understand how the final system works. It's possible to study how the final system works, but that's a whole other extra research project. More on that later. But if it does something we don't want, we can't just find the instruction that contains the mistake and fix it. There aren't any instructions. It's a bunch of unlabeled numbers that no person chose. So instead of fixing it directly, we have to do more training, after which we still have something we don't really understand. So it's closer to training an animal than it is to building a machine. So that's the broad technology of neural networks. They're used for lots of different tasks: computer vision, content recommenders like here on YouTube, game playing bots, protein folding predictors. But the specific kind that gets the most attention is large language models, or LLMs, the most famous one being ChatGPT. Many of you have heard way more about LLMs than you care to. If you haven't heard of them, welcome to the future. The computer can talk to you well enough to make people fall in love with it. If you make the mistake of browsing the internet, you'll see a lot of hype about LLMs, and you'll also see a lot of naysaying.
The ability to speak does not make you intelligent. Now get out of here.
On one hand, you have these autocomplete engines that can't count the number of R's in strawberry, but on the other hand, you have billions of dollars in investment and warnings from very serious people that the world might end in 2027. It's become a polarizing topic. Some people here are going to be bothered when I point out things LLMs are bad at, and other people are going to be bothered when I point out things they're good at. And I'm not sure what to tell you, except that the more strongly you care about something, the more important it is to make sure you really understand it. So I'm going to do my best to give a balanced take on the state of LLMs. We'll start with summarizing how they've improved since they first came out, and then we'll look at things that they're still bad at. So first, we just have to clear up a misunderstanding. A minute ago, I said that LLMs are autocomplete, and there's truth to that, but it hasn't been the whole truth since 2022. It's true that the first training task is predicting text, that much is true, and at the end of that step, which is called pre-training, what you have is essentially a fancy autocomplete tool. But starting with ChatGPT and its predecessor InstructGPT, LLMs have had an extra layer of training. Reinforcement learning with human feedback, where they're trained on examples of what humans prefer in terms of correctness or helpfulness or whatever the company decided. When you're using ChatGPT, it doesn't build its response by repeatedly picking the most likely next word. Instead, it's repeatedly picking the next word toward building a whole response that a human will like. And this might not seem like much of a difference, but to illustrate, let's think of two ways you might build a chess bot. The first way is you could train it toward the goal of mimicking moves of humans. Autocomplete, but for chess. The idea here is relatively straightforward. There's a ton of data about chess, so you have a bunch of training positions, and at each position, you know how common each legal move is, and picking more likely moves means the bot is doing better. This might make it decent at playing chess, especially if you had it mimic the moves of grandmasters, but it would never become better than the grandmasters this way. At best, it would be about as good as the average player in the training data, which is how people think about LLMs. The other approach would be to train it toward the goal of winning games. This is harder because you can't just depend on training one move at a time anymore. What we care about is a whole game, which involves a sequence of many moves, much like how writing a paragraph involves choosing a sequence of many words. Reinforcement learning is designed for this kind of situation, and it's how we have made the extremely powerful chess bots we have today. And these chess bots don't predict the moves of grandmasters. They find better moves, and they crush the grandmasters.
Can you beat your phone at the highest level?
No, no chance.
And this is why reinforcement learning for LLMs is a big deal. LLMs are not mimicking human text one word at a time. That's the first step, yes. But by the time you're using them, they're choosing a sequence of words toward a goal. And that's why ChatGPT feels so different from the autocomplete on your phone. They say that the pen is mightier than the sword, so if LLMs got as good at picking words as chess engines are at picking chess moves, that would be kind of a big deal. Are they actually gonna get that good? I don't know, maybe not, hopefully not. As complicated as chess is, picking words is a lot more complicated, so I'm not saying they'll be as good as chess bots, but we should start our evaluation of them with the knowledge that it's just not accurate to say that LLMs are merely autocomplete. So let's have a look and see what we can see. I checked a recent model, Claude Sonnet 4.5, and it did pass the strawberry test. I was suspicious that it might have seen this before though, since it is the famous example, so I tried having it count the number of E's in pineapple pamplemousse. Yeah, I guess they're still having some trouble. However, newer models have an extra part. Instead of giving their answer immediately, they get to write down some intermediate text beforehand. Basically, they get some time to think instead of needing to say the first thing that comes to mind. It turns out, thinking before you speak makes you smarter. Now, look, I realize it's not the same thing as human thought. Nobody wants a semantics war, which is what this always turns into. I'm just using the convenient word. But anyway, these are called reasoning models, and when I turn on extended thinking mode, Sonnet can suddenly count letters. This is still a pretty low bar, of course. Sticking with wordplay, I decided to try asking Claude to make a poem about bees being good at making honey, but without using the letter E, just to see how it would do. And if you've been on this channel before, you'll be no stranger to the idea that making predictions is a great way to keep yourself intellectually honest. So let's try that out. Do you think it'll avoid all the E's? Will it do the other stuff I asked? Will it be a good poem in other respects? You might over or underestimate how well it'll do, but making a prediction stops the tendency we all have to think we knew all along what would happen. And in that spirit, this was a genuine test. I only asked once, I didn't have it do any other tasks and cherry pick the results. I'm showing you the real results of the real first try.
I mean, pretty good, honestly. It does what I asked, including successfully avoiding the letter E, but also it has pretty good meter and each stanza has a distinct purpose. It even has this part where it goes meta, kind of cheating, but if a human did that, I'd call it clever. Is this gonna let it take over the world? I mean, no, of course not. It's a poem. But it is an illustration of how these things are improving. A human could perform this task, and a human with talent and experience in poetry could probably do better. But still, it requires attention to the meter, the meaning of the words, and the letter content of each word all throughout. If you're not impressed, I don't know what to tell you. And sure, counting letters is a bit of a different task, so it's a flawed comparison, but if I told you 5 years ago we'd have systems that could do this well on this task, and they weren't even specifically designed or trained for poetry, you would have thought I was crazy. They also couldn't reliably do arithmetic before, but now they can. Also, an LLM achieved gold medal performance at the International Math Olympiad, which requires writing novel proofs. GPT-4, which came out way back in the ancient days of 2023, could already do better than most people at most standardized tests. And now, most models don't even report scores on those tests, since it's old news that they get almost everything right, and the tests are no longer good tools for measuring improvement. So people keep making new, harder tests, which the models keep doing better on. They're also getting better at coding. This is another polarizing issue, and they certainly have their problems, and they seem a ways off from actually being as good as an experienced human. But whether you're looking at adoption or competitive coding performance, or just try them out to see how they do, they're clearly getting better. They're also getting better at images. Less than a year ago, people were talking about how ChatGPT couldn't make an image of a truly full glass of wine. It would always make an appropriately or commonly full glass of wine, not an actually full one. Alex O'Connor made a video linking this to philosopher David Hume's ideas around empiricism, and suggested that one explanation could be that perhaps ChatGPT just couldn't think abstractly in the way that humans can. Alex is a disciplined thinker, and so he rightly just pointed out that possibility rather than making any strong claims about it, and I recommend his channel very much. But now ChatGPT can do it with a simple prompt. Okay, so that's not actually full to the brim, but if I'm clearer about what I want, it can do it. And it's possible that OpenAI specifically added some training for wine, so I decided to try something even further from a typical glass of wine. Seems pretty unlikely to me that they specifically trained for this one. Up to you. The reason for the wine glass issue wasn't some fundamental limitation of AI. It was that in older versions, ChatGPT wasn't actually drawing the images itself. It was working with text to create a prompt, which it would then pass to OpenAI's separate image generator called DALL-E, which is what would actually create the image. Instead of one system that understands both the text and the image at the same time, it was a collection of narrow systems hooked together. But now, ChatGPT and other systems are natively multimodal, meaning they're trained on both text and image tasks together, allowing them to perform them in a more integrated way, which leads to better results. So I've been pretty bullish about AI for the past few minutes, so let's have a quick palate cleanser. I tried again in a fresh chat, and I got this. So yeah, we've still got some world consistency issues going on, but if you compare what we've seen here from ChatGPT, it's worlds better than previous tools that couldn't go beyond a normal glass of wine without putting you into full fantasy mode. Now, there's yet another kind of model called an agentic model, which is just a fancy word for a model that can interact with an environment of some kind and take a series of actions based on the results. Instead of one prompt, one response, and done, it uses a behavior loop to potentially complete multi-step tasks. One example is if you ask an LLM to search the internet for some reason, it'll create an initial output that interacts with a web search tool, and then it'll wait for the responses, read the results as a kind of other prompt, then tell you about them. And by the way, these different kinds of models, reasoning, multimodal, agentic, they can all overlap. So an agentic model can typically think ahead a little bit like a reasoning model, and if they encounter an image, they can work with that too. The abilities are all combinable. At most of the tasks we've talked about so far, the AIs are arguably near or in some ways better than most humans. But at long-running real-world tasks, they kind of suck. From the perspective of AI taking over the world, this is great news. They can't reliably book a flight, and taking over the world is more complicated than that. Though, to be fair to LLMs, I guess I haven't booked a flight in a while, but the websites are bad. They're getting better at longer coding tasks and a bit better on simple computer use tasks, but performance is still pretty rough on actual remote work tasks. And they have another pretty severe limitation, which is that they can't continually learn. Once they're done with their giant training runs, they're done learning. They can sort of learn by using information from earlier in the conversation context or store information from previous chats, but for an LLM to get smarter, it has to do more large-scale training. So as long as they can't do trainings on their own, humans have a decent shot of staying in control. OpenAI is planning to automate the research process.
So robots building robots.
Authorization code, please.
Well, that's just stupid.
So that's a summary of how LLMs are doing. Are things going to keep getting better? It's hard to say. There's been this weird thing where if you make the model bigger, train it for longer, or give it more data, its performance at predicting the next word during pre-training improves by a predictable amount. As far as I'm aware, nobody knows why this is. It kind of makes sense that they would tend to get better if you put more into it, but why this particular pattern? We don't know. It's just what seems to happen. But this is a big part of why an investor might be willing to give an AI company money. There's a reasonable case to be made that more resources will lead to something more capable. And also, nobody knows exactly how that pre-training performance translates into real-world abilities like multiplying numbers or passing the bar exam or booking a flight. So it's a big mystery in a lot of ways. But the performance improvements follow a power law, which means diminishing returns. If we could scale these things infinitely, maybe that would get you an omnipotent super being, but the economics might break down long before that. This is just my intuition, so take it with a grain of salt, but it does seem like training toward achieving longer tasks is the kind of thing that just takes a lot of work. So the compute requirements for extending task length might be enormous, and beyond what investors can muster with speculative investments. And this is the main reason I feel relatively safe in the short term. But I can't actually claim to know. Speaking of things we can't claim to know, how did Claude actually write that poem? You could look at its chain of thought and say, oh, well, you know, it brainstormed words and it made notes about structure, but that's how we explain how a human works on poetry. Or you could take a more technical approach and describe its training and how the transformer architecture works, and then wave your hands and say poetry at the end. But that's also how we describe humans writing poetry. We just say neurons instead of transformers. Now, don't misunderstand me. I'm not saying these work the way humans do. They don't. But in both cases, we don't get it. So we have to resort to general descriptions rather than the detailed explanation you could get for any other machine that we can build. Now, we could figure it out. It's possible to dig into the models and look at all of the little numbers and reverse engineer what's going on for a given behavior. In a paper from early 2025, MIT researchers discovered that LLMs use a helical structure for representing and adding numbers, which is wild because our number system also has sort of a helical nature to it, even though it is a different system. Anyway, as amazing as this work is, it's only one small piece of a giant set of capabilities, and models and capabilities are growing way faster than we can characterize them. The overall picture is that LLMs keep getting smarter. It always seems like they're showing their limits, but then they just get better. And this doesn't mean it'll keep happening forever, but we just don't have much we can really say about where the ceiling is for the current AI approach. And we don't know how they work, and we don't know how our own minds work for that matter. We're just kind of in the dark and also sprinting forward, intentionally in the direction of a super powerful alien. So I've been arguing that I don't think it's valid to say that we're safe from AI taking over the world.
At the same time, I don't think it's valid to say AI will definitely take over the world. So it's somewhere between 0 and 100%, which isn't too terribly helpful. So it'll be good to try to put some numbers on it. So that's what I'm gonna do right now. Will AI take over the world by 2030? I'm gonna give that a 1% chance, right? And I should also say, what do I mean by AI taking over the world? It's hard to say exactly, it could take a lot of forms, but basically the AI is self-sustaining, can maintain itself, and has some growth trajectory that humans aren't able to stop, right? So some form of that, that's AI taking over the world, because once that happens, as we saw before, speed advantages and the ability to copy can really just take off. So why 1%? It's just a numerical distillation of my general confidence level. I would be pretty surprised, but I could see it. If we go all the way to 2040, I'm gonna say 5%. Why 5%? It's a round number that's a bit higher. It's not, look, I don't know exactly what the number should be, but it should be higher, right? We'll have more time to make more discoveries, maybe specifically on AI research, or maybe there's breakthroughs with energy. Maybe we figure out fusion and suddenly energy is very cheap, which makes it so our old ideas of scaling just with compute become a lot easier and we can push that even further. Or maybe something else happens, right? There's a lot of possibilities. And so it goes up to 5%. Still, I'd be surprised, but it starts to become, instead of 1 in 100, it's 1 in 20, right? If you roll a 20-sided die and you get a 1, which does happen, then AI takes over the world by that point. If we go all the way to 2100, the number I put on that is about 70%. Basically, at that point, I think we'll figure it out unless something stops us. So maybe there is some fundamental barrier to getting a computer to be as smart and general as people, right? We talked about some of those assumptions earlier, and it seems like the assumptions are true, but maybe they're not. So that could stop us, or maybe society collapses in some way. There's a big war or something, and then we just can't or don't want to fund AI research anymore. Or, maybe it happens, AI does take off, but it actually goes well and doesn't take power away from humans. So, there's different possibilities, but overall, I put 30% into those other possibilities, which aren't all good, but then 70% toward AI taking over the world. And this assumes that we're on our current trajectory where we're just kind of sprinting at capabilities, and some people are working on safety and understanding it, but really where all the money's going is just making them bigger and trying to make them do more stuff, and kind of, it'll be fine. Safety is sort of essentially what our current approach is. So anyway, again, these numbers are just my intuition. They are informed by doing a lot of reading and thinking and discussing about this, so they aren't completely out of nowhere, but it would be reasonable to disagree with them. A lot of people do. Many people would say that the numbers should be a lot lower, but a lot of people would also say that the numbers should be a lot higher. And if we look back at Geoffrey Hinton and Yoshua Bengio, the two most cited computer scientists that I mentioned earlier, they give numbers that are about in this range.
I think you said there's a 10% chance that AI will lead to human extinction within the next 3 decades. Has anything changed your analysis of that?
Not really. I think 10 to 20.
Oh, you're going up.
If anything.
But those aren't the only considerations, right? There's also the other potential downsides of AI. In general, they're less of a big deal than literally ending human society forever. But they are more real, right? Some of them are already real or more likely in the nearer future. Then there's the benefits. And the benefits are sort of, I do think they're real. They're potentially real, right? If we get a computer that can do productive cognitive work, that's gonna accelerate our progress economically and scientifically. We're gonna all be a lot richer. Actually, all is sort of an interesting word for me to use because there's a question about distribution, right? It could be that everyone's richer to some extent, or it could be that few people are way richer and everybody else is economically irrelevant, and it's worse for most of us. It's possible. But anyway, this is supposed to be the upsides part. There are real upsides, right? Curing cancer, being richer, like those are good things, right? That could happen if a machine is able to do useful cognitive work at a human level or potentially higher, right? That's there and that's worth paying attention to. And this is the reason that all that good stuff is the reason people want to do it, right? That's the reason people work on it. And I have some excitement about that potential. I can't really tell you how to weigh all of these things. There's a lot of uncertainty in all of them. But I'll give you my overall hot take, which is that honestly, it's a very tepid take. It's that maybe we could all just slow down a little bit and concentrate on one, understanding how these things actually work that we're making, and also making sure that we can control them, right? The downsides are already showing that we're having trouble controlling them. And if they do get more powerful, it's going to be harder to control them. It is something worth taking seriously. I just think if we slow down and try to have better understanding and better control, the expected goodness of the future becomes a lot higher, right? Of course, it would mitigate the downsides to go slower and be careful. The upside is a little bit more confusing, right? A lot of people will say that AI safety or slowing down on AI is actually a bad thing because it delays the future benefits. And I think this is true, right? If we did cure cancer, and AI is a part of that journey, say slowing down costs us 5 years, we cure cancer 5 years later than we would have otherwise, that's a big deal, right? That's a lot of people suffering and dying prematurely, which could have been avoided, right? That's a big deal, right? And I get it. Look, I have cancer in my family. I would really love it if we got rid of that, right? So, there's a cost to slowing down for sure. But, as big as that 5 years would be, if humanity loses control and an AI takes over the world, all of that future value, all of that upside is wiped out forever. So, delaying a little bit, even though I agree it is a potential big cost, it seems like the wise move as a whole. I don't have some magic solution. Pausing on capabilities research until we actually understand how these things work and how to control them seems pretty obvious, but people have different ideas about what safety is, and nobody wants to stop and then let another company or another country get ahead of them. So it's difficult. It seems like we would need an international agreement of some kind to establish how AI should be regulated so it can be done safely. We all want to win the competition, but nobody wants things to get out of control. So it seems like we could do that somehow. However we do it, though, it is going to take a lot of people arguing and discussing and learning and figuring out how to do it safely. So the best thing I can do is point you toward a bunch of resources to continue the conversation or learn more. On his website, Yoshua Bengio discusses his views and he has an FAQ. It's worth a look if you have some specific objection and you want to see what a real expert on AI thinks about it. He's also done talks, interviews, and debates if you prefer that format, and Jeffrey Hinton has been making a lot of appearances as well. There's also a lot of great YouTube channels. The original AI safety YouTube channel is Rob Miles. He was doing this before it was cool. He's also been on Computer File a bunch of times, and he voices videos for Rational Animations, which is another great resource. Silly Conversations is a newer channel that I quite like that takes a more comedic approach to the topic. A real hidden gem is Go Meta with Ollie Sharp. He's been doing more book reviews and economics lately, but he has some great videos on AI and on AI safety. For more interview-style content, there's the Dwarkesh Patel podcast, and there's also the Big Technology podcast with Alex Kantrowitz. Both shows get great guests, and both hosts ask great questions to stimulate deep discussion. Nikki Case, one of the best and most playful explainers out there, just finished a big series on AI safety. I haven't actually gotten a chance to look through it myself because it dropped right before I recorded this video, but I like Nikki's other stuff enough to be confident I can recommend it anyway. The Future of Life Institute has a wide range of resources for a general audience. They recently published an essay called Control Inversion, focusing on what it would actually look like to control a powerful AI. They also do policy research and advocacy if that's up your alley. They also have a program called the Digital Media Accelerator to help people fund projects about AI safety. So if you have your own idea for communicating about this, they might be able to help you finance it. They helped support this video, for example. The Center for AI Safety has a great newsletter. They're mainly a technical research organization, so they're great if you really want to get into the weeds. Links to all of these and more in the description. And last but not least is 80,000 Hours, who sponsored this video. I don't usually do sponsors because I take the idea of asking you to spend your money somewhere very seriously. But when 80,000 Hours reached out, it was easy to say yes because they don't want your money. They just want to help you help the world. 80,000 hours is the rough number of hours in a career. And their goal is to help you find a career that does the most good possible, tailored to your own preferences and skills. If you're toward the beginning of your career, they have articles aimed at understanding various possible career choices, the impact potential they could have, and the path toward getting started on them. AI safety is one of these areas, but if that turns out not to be a fit for you, there are many others. If you're ready to work, they have a job board to help you find opportunities with mission-driven companies. They even do one-on-one career counseling for personalized advice. They're a nonprofit funded by donors who support their mission, so all their services are free. If you're curious, you might as well take a look. There's a link in the description. If you use that, they might tell me lots of people clicked on it, and that would feel nice. But seriously, it is a really great resource. If you'd like to argue with me about it, I do a Patreon live stream 1 week after the publish of each video. That's at the $10 tier, and at the $3 tier, you get your name in the video, like all of these fine folks. And whatever you choose to do going forward, I appreciate that you've watched until the very end of the video. Yeah, we got this. We're gonna be fine. Everything's gonna be fine. It's gonna be great. It's gonna be great. Okay.